So this is the first video since I have sort of publicly stated that, hey, I have filed for a patent for a new appraisal method. And I'm going to back off from new appraisal method in a way. In some ways, it's a new paradigm on the sales comparison approach. And I believe that it's what the sales comparison approach always should have been. So in order to do that, we're going to have to back things up a lot. And there's a lot of conceptual building blocks to understanding this method, why it's necessary, and sort of the implications of it. So let's begin today just with where we are now and sort of the illusion of determinism. So if we look at a sales comparison grid, we can notice a few things. We have a grid set up in such a way that we are we're applying adjustments for various features. So these would be variables that are different, that I have determined that there's a dollar amount that describes the market reaction. And what is interesting about that is we speak in terms of supporting an adjustment. But what I want you to notice is let's just take the concept of correlation. If we just look at this grid, I literally just pulled this report at random from my files, and it is as good of example as any in the way that we look at the sales comparison approach, the way we think about it, and the way we report it. In particular, the way we review it. So the users of appraisal services and what they believe this information conveys. Is it really possible to be able to determine an adjustment? So let's take this this little grid here and make a few observations to this point. And again, I'm going to really focus just on the idea of correlation, which is super important in this. We have three properties here that are gridded. This is not actually the only three. This is comps 4 through 6 in this particular appraisal. And I chose these because it's real easy to see correlation with these three comps. So I have the largest home in this data set. If I say data set, I mean the three comps we're looking at right here. I have a property that is 3,021 square feet, and it is also the largest lot, 8,913 square feet. So if I compare that, say, to this first comp in the grid right here, then you're going to notice that it's a much smaller home and it's a much smaller lot. So again, if we're just isolating these two sales together and looking at what each one says, we're going to have to admit that the gross living area adjustment and the site adjustment are tied together. I cannot support the site adjustment without actually considering what the gross living area adjustment is, because they're tied together. So if I were to say, oh, I have supported the site adjustment at whatever this might be, maybe $5 a square foot or something, that $5 a square foot only has meaning in the context of, well, what am I adjusting for gross living area? They're correlated together. So now this leads to some questions in terms of how we talk about adjustments, what they actually mean. And there's some things that have to come into play here. We're telling a story that is deterministic. I have determined that this is the best adjustment for site size. Well, I can only determine that in the context of other things which I have held constant. So I can only make any sort of determination if I'm applying a whole lot of constants, which means essentially I am trying to remove uncertainty in every other area so that I can determine a adjustment for a feature. So this is what we've been taught to do our whole lives. So if you begin in middle school algebra, the first thing that we're taught is you isolate your variable and you simplify. And so if we try to do that in appraisal, it's going to give us some comfort level. It's going to feel good. It's going to feel right hey, I've done what I'm supposed to do. I've tried to isolate this, and now I've been able to determine something. But when I go to the next adjustment, every one of those next adjustments now is something that I have already, in some manner or form, isolated in order to make a deterministic conclusion about site size. So if then I am making a deterministic conclusion about gross living area, I can't make any changes there because it's going to affect the conclusion that I came to regarding site size. So these things are interrelated. This is what correlation is supposed to measure, these interrelations. So I would say that this is a structural interrelation between site size and gross living area. So as an analyst, as somebody who is looking at data, trying to draw conclusions from that data, this creates a problem. So how do I unwind this? Now, in some I guess deterministic structures that we would try to apply, they might say it doesn't matter. Combine those two variables together and draw a conclusion. Well, that might work in certain circumstances, except what if the subject property doesn't follow that same structure? What if I have other data points that I would like to add which also don't follow that structure? Unless I'm keeping a keen eye on correlation, I'm going to start introducing bias and error into my analysis. So that is one thing that we can look at and say we're used to looking at this, and the way we're reporting it, the way we're thinking of it, is in a deterministic way. Something else we have to consider in terms of this deterministic framework is each one of these elements in and of itself, it has uncertainty. And that's because when we're applying an adjustment, what we're saying is this is the aggregate of how I think the market's behaving. And I'm going to term that the shape of our market. So when we are looking at how a market functions, how buyers and sellers are behaving in a market, there's a certain shape to that, how they function together. And each element has uncertainty. So anybody who's ever heard me talk about my class, Creating Formulas That Work, a small sliver of people out there have taken that, and they've heard me talk about uncertainty and all the different layers of uncertainty that come into buying and selling decisions. So the price itself is a function of a great deal of uncertainty, because every individual buyer and seller, those interactions together are full of uncertainty. And we, as appraisers looking at data, we can never be certain of the thought processes of the buyer and seller which went into that price. And so when we're looking at aggregate differences, when we're looking at market value, okay, well, if I were to combine all those buyers and sellers together and call this a typical buyer and this a typical seller, well, what's that aggregate action looking like? And what those aggregate actions really look like are probabilistic structures. So you can think of each one as maybe a probability distribution. So maybe it would be very few buyers and sellers who would combine in a way that didn't care what site size was. It's not going to affect the price at all. And maybe there'd be on the other end of the spectrum, very few buyers and sellers who would interact together and say that was the most important element and that was the biggest driver of price. The market reaction is something in between, something in the middle, and there's not a specific number for that. It is a probability distribution. So there is a most probable number, but ultimately, when we're talking about each individual number represented on this page that we're looking at involves uncertainty. So when we're looking through a deterministic mindset and using deterministic frameworks, what we're doing is ignoring the fact that that uncertainty exists. And so what we need to learn how to do is to work within the bounds of the real world uncertainty. And so we're going to talk a little bit more about that in terms of uh, lots of different features of, of the process, of the method that I'm beginning to teach you. But first, we have to begin by sort of wiping the slate clean with what we've always thought that the sales comparison approach is, and opened ourselves up to the fact that we need to be willing to rethink if the structures that we're applying to this approach to value are best suited for the level of uncertainty that's inherent within it.